Good morning from California. Good afternoon in Europe. Good evening in Asia. I'm Ambrose Conroy. I'm the founder of Seraph Consulting. It's a pleasure to be able to talk with you today about software-defined vehicles. I've spent a lot of time working within the automotive sector, and the changes that we're seeing and the pace of change right now is accelerating far beyond what we all thought was possible. Pressure from China, the new advent of software-defined vehicles, and over-the-air updates that were driven by Tesla are really transforming the face of the industry. OEMs and tier suppliers have to change the way they work together. Value will shift, challenges will arise, and we're all going to be working differently. I'm lucky enough to be joined today by our partners from E&Co. Dr. Engelbert Wimmer and Holger Rothog are here to help us understand a bit more about software-defined vehicles, what it means for the supply base, how the OEMs are leveraging it, and what consumers are expecting. With that, I'd like to turn it over to Dr. Engelbert Wimmer, who will take us through some background on software-defined vehicles, help set a baseline for all of us, and then we'll continue into the discussion. Over to you, Engelbert.
Good morning to the US. Good afternoon to my colleagues here in Europe. My name is Engelbert Wimmer. I'm the CEO of Entrepreneurs and Consultants, a partner of Seraph. And we are talking about one of the most exciting developments in the automotive industry, something that will reshape the industry even more, I think, than the electrification of the drivetrain. This is the software-defined vehicle. So why did we at all land in this position, almost forced to talk about the software-defined vehicle? Let us go back a couple of years to the mid of the 90s, when we were distributing ECUs across the vehicle, and each of those ECUs would have one or more functions to serve to some steering requirements in the vehicle. All those ECUs became more and more complex. The higher order the software was that ran on those modules, the more the requirements grew to connect all those ECUs, which led to a massive increase in complexity, in weight, in cost of the wiring harness. We landed up in a region of more than 100 ECUs being distributed across the car. And that, of course, was a driver for complexity and cost that was unbearable. The reaction was then that we created ECUs that were of higher power, higher magnitude, higher complexity, that integrated more and more of those local ECUs into one bigger, more powerful box. But even if you would integrate some of those functions in what we called a domain controller, the need for cabling was still quite massive. To fight all that, the architecture of the vehicles grew into something that we nowadays call zonal architecture, which means that every one of those zones, you can think about hemispheres of the car. Yeah, it's like a brain hemisphere. We have a left and a right brain. So you have in the car a left and a right front brain and a center or a center left and right brain. And they would be cabled together with a much more powerful network so that you would have a zonal architecture, as I said, in the car. More and more complex higher order functions would be integrated as software on those controllers. That was the means to fight with complexity and also to integrate the dependent functions on one ECU so that you can actually switch signals between the software modules on the same platine. It was a means to fight the heterogeneity of those ECUs because you would have, in some cases, very complex steering devices, and in others you would have quite simple actuators where you switch on a light. That all was integrated into one standard architecture per OEM, and everyone tried to decouple the delivery of the hardware platform from the software that delivers the functions on top of those hardware modules. Think about your mobile phone. The mobile phone comes now generation by generation with a hardware platform that is very independent of the functions above. And this is exactly how we define a software-defined vehicle. The software-defined vehicle is a vehicle whose functions, features, and operations are largely controlled by software rather than fixed hardware systems. It's like your iPhone, which gives you functions that are defined by the apps and not by the hardware that it runs on. You can have a camera that is primitive, or one of those, with 4 lenses integrating the camera function. What you can do with it is very much defined by the apps that use the hardware. And like a smartphone, a SDV can be continuously developed through over-the-air updates and new software functions, like you can load new apps in your phone, which represents a revolution in the design, production, and use of automobiles and paves the way for personalized, intelligent, and connected mobility. Our prediction is that this will completely reshape how OEMs are defined, organized, how they work, what they do, what the content of their work is, how they collaborate with the tier ones that supply software into this ecosystem, and how they open their ecosystems to work with other partners in the mobility space. A massive revolution that is now not anti-porters, we are in the middle of it. Now, the why of the SDV, what problems do we intend to fix by having SDVs? Of course, lifecycle cost. You can reuse some of the modules in the next generation, and that should mean that the cost of software development is over the time lower than it is today. It's higher customer value because you can have more function for the same money. You can even have functions that you acquire when you already have the car for a long time. It's the handling of complexity because if you're doing it right, you have one software stream that you need to maintain, and not a software version vehicle by vehicle or project by project. We should be able to speed up the cycles of our product development significantly. We think that 18 months is the target that you should cut out of your development process by applying the principles of software-defined vehicles. So you should be able to speed up product development by 18 months. You should be able to have a clear architecture trajectory because the zonal architecture that we see today is not the end game. This is an intermediate game on the way to, at the end of the day, come up with a central compute architecture where you have one central platform that integrates all the functions, has redundancy and a certain logic of modularity so that you can have the increasing levels of autonomous functions on the same platform. It should also drive the next generation of processes, methods, and tools in preparation for massive use of AI in your product development process. So without software-defined vehicle, there is no need, no benefit of artificial intelligence in defining car projects and software projects in the automotive industry. But once you have it, it is the baseline. And lastly, it is a means to fix errors from observation to the bug fix to integrate and test over hardware in the loop and software in the loop and roll it out within less than 8 hours. So from a corner case that has a problem in the field to fixing it for all the fleet in less than 8 hours, that's the target that we aim to shoot for. That's quite impressive compared to where we are now, where in many cases we have months or even years to fix errors when we need to roll out software updates into the field. The impact of the software-defined vehicle to costing and speed will be massive. It will absolutely redefine the interplay between what used to be a OEM, original equipment manufacturer, could be an original software delivery unit, and its suppliers. The impact will be huge. We will have as an impact the need for a complete virtualization of the hardware, cutting 18 plus months of the product development process. That's a massive change. That's a significant change. And that will divide the world between those survivors that are able to deliver these new processes and the ones that are not able to transform their units into modern software-defined working processes in the product development area. We will see significant cost savings. Whether these will be per vehicle or per function remains to be seen. My prediction is that the overall cost spending per car will remain pretty much where they are today, but the amount of functions that you can get per dollar spent will absolutely increase through modularity, reuse of modules, and of course the reduction of code repositories, because at the end of the day, software-defined vehicles will have only one pipeline through which they are being processed, through which they are being maintained, tested, deployed. We see a massive reduction of the tool sets that we will maintain, albeit a much higher order of complexity of those ones, leading into a continuous integration, continuous deployment pipeline, where pretty much as we have learned by the first mover of Tesla, have one flow of activity leading into one status of software that is being rolled out across the fleet. And we will see a massive increase in robustness. And for everybody that today works in the software space, that looks a little bit like a paradoxon because our pipelines are typically not so robust. But we will see a massive increase in robustness of the system development and the digital homologization to roll out car projects across the planet. The secret sauce to achieving that is the integration process. So how do you integrate all those software modules in all those proprietary niches that everybody in every OEM conquers so that you can maintain this unique pipeline that delivers your code repository, that delivers through your code repository. And you can only do that if you have a very good understanding of the architecture that you're working on, the architecture trajectory. You need to be an architecture owner. This is not the case in most of the OEMs today. However, we see that every one of the OEMs think Android versus Planet iOS versus all the other mobility systems that we used to have in the beginning of the mobile revolution, that we have these ecosystems being presented where one branch or one leg would be placed in China and one leg is always placed in the rest of the world. I'm not going into the details of these ecosystems, just giving you a broad overview of some of those ecosystems so that you can understand that every architecture currently is being developed in two legs, one in China, one in rest of world, and that everyone tries to firm up partnerships to be able to support software-defined vehicles in the future. Now, what very important and interesting one is also Stellantis. Pretty surprising how mature they have been developing their ecosystem. Now, before we go into the discussion, a couple of lessons learned from our brief excursion to what is software-defined vehicles. We will, for political reasons, need two independent architecture stacks in all OEM ecosystems, one for China and one for the rest of the world, simple by legal requirements. And it will not be easy to work with cloud architecture in China as one of the reasons. The second one is if you want to maintain the speed and the process integrity of your software-defined vehicle development process, there needs to be a strong central coordination to align the roadmaps and also the architectures, the cycle plans, and the cost across your automotive sphere. All the OEMs have so far developed India as a software engineering workbench, which in all the cases that we looked into was driven more by talent availability, think preparation for the time of AI, rather than cost. If you are entering the game now for cost reasons, you already lost a decade for preparation. Better not then go into India if you not already have a proprietary and functioning software unit there, because the ramp-up cost of building such a software center, engineering center, especially if it is captive, is a decade and costly. AI in software-defined vehicle is only nascent. It has huge potential. We have, of course, in the area of self-driving systems, used machine learning as a means, but the real use of large language models, of learning loops, of shadow fleet mode, etc., is in the very, very beginning. Even when we see the use of the Waymos already being rolled out, etc., the real effect of AI is only scratching the surface of the potential. And finally, and this is our firm assumption, software-defined vehicles, as we think that it will develop, is still in day one. There's a long road ahead to central compute from the architecture and 48 volts and whatever you have in these new architectures. We see that players that have the AI competence, like NVIDIA, currently enter the race with a potential own product. They call it a test vehicle or demonstrator vehicle. But seeing the development there, we expect more of those electronics companies and software companies to be in reach of something that can be a real competitor in the area of software-defined vehicles. And at the end of the game, there is the robotaxi on the horizon. Waymo and the others are just the first streak on this development. In 10 years, the world will look very different. Probably the automotive transformation that we will see in the coming decade until 2035 will be more and deeper and more serious than the history of the car in the last 100 years even was. Thank you. I hope that was food for a discussion, and I'm looking forward to my colleagues reflecting on the topic.
Thank you, Engelbert. That was fantastic. I think it'd be great to take a moment to Engelbert and Holger to let you introduce yourselves and a little bit of your backgrounds and who you are. Engelbert, do you want to go first?
Yes, thank you. I'm a 25 years engineer in the automotive space, founder of a consulting firm, friend of yours since more than 20 years. I hope that you excuse that our friendship goes back already more than 2 decades. And I've been working in this space in the German industry, but also the Japanese, and very intensively in the last 15 years, delivering several car platforms and helping also my friend Holger here in some of his projects.
It's amazing how time flies, Engelbert. Holger, do you want to give us a little bit of background? And then we'll jump into this.
Happy to do so. I've been working my complete professional life in automotive. In the past, specifically focusing on ADAS development areas where you deal with large amount of data and do have a necessity to have things in place, which we've been talking about today. Before that, I've been 10 years with Volkswagen, been able to have different leadership positions from diagnostics into the product line and finally into the Carrier organization. So I've been part of that organization trying to change from hardware-driven development into the software-defined part. And before that, on the consulting part, helping companies actually to deal with all those changes coming up. Happy to be here and have that discussion with you.
It's great to have you both. So I'm going to invite everyone to start asking questions. If you have questions you want to ask, please put them in there. I'm going to start off this discussion with a question that we got from Peter Hassenkamp. Peter asked, he's curious on the panel's opinion on how OEM strikes a balance between in-house developed software versus purchased or partner software. No OEM can do everything, obviously. So what is the priority for the OEM and how deep in the software stack do they go before they find it simpler to purchase from others? Keen to get your view on that.
Maybe I give it a start. You know, there is a very serious precondition that we have to remember, which is Conway's law. And Conway's law is stronger than every development pattern that you could have otherwise. So every block of organization that you create that interacts with another block is reflected in the software that you define. And the more of those separations you'll have, the more separations you will find in your software, which means that all the interface problems and the difficulties and integration problems that you will have in between the organizations are also reflected in the software. So we will see a massive reduction in those interfaces in the future, in tendency in-housing much more of the software development. And if we look into what we see in China, in the Xiaomi organization as a benchmark, you'll see that the in-housing trend is massive. Yeah, they try to get to a very flat organization, and that is also reflected in a very flat software architecture. So I see that the long value chains that we have will be cut to become much shorter. And if you would ask me how I would do it if I would be owning an OEM, it would be very, very flat. That also then reflects how you would partition your software, very much organized by value streams that are not domain specific. very much technology driven. So the classic integrator function of a tier one that integrates components to the nth tier is probably not what you would see in the future. Holger, what do you think about it?
Adding to what you said, I would look at the capabilities I need to have as an OEM, right? And that was also the question Ambrosio asked. What do I need to do in-house and what do I have to enable so that others can actually work with me? And to me, it's basically I need to own the CI/CD environment so that everyone can work on a holistic environment, is at all point in time knowledgeable about where they are in development, how this works in interconnection with all the other parties who are developing at the same product. And secondly, I need to have a strong governance function on it. I need to make sure that API contracts are in place, are being executed all the time, and stay relevant for all the time when others work together. And you already have the situation if you would do 100% in-house today, because all of the OEMs have different locations where they work, right? They collaborate already globally today, taking China a bit apart due to the latest regulations coming into the game, but they have development places in the Far East, in East Europe, in India, in Central Europe. So they already have the situation that they need to impose a coherent way of developing collaboratively and have all those capabilities in place. So I would focus on these combined with what Engelbert was saying on the organizational setup, empowering this.
I think that's very interesting. For me, it leads me to the point of wondering, we look at the Chinese do this very, very well. There are a couple of Western automakers who aren't bound by the legacy challenges that they have. Yeah. We've got Tesla, who during the chip crisis really, I think, did a great job managing that because they controlled their software stack and they were able to make changes to chips. They were able to change things very quickly on the fly. We've got Rivian, who just sold or joint ventured their software stack with Volvo, Audi, Porsche, that family. How do we see this evolving? How do we see leadership coming? And will software stacks become a commodity that OEMs partner on, or do we think people are going to own these themselves?
Well, there are some initiatives ongoing. We have the software-defined vehicle initiative funded by the Eclipse Foundation, where a lot of companies, OEMs, tier one suppliers, but also software suppliers along the stack are actually collaborating with the goal in implementing an open source environment where everyone can actually put their capabilities into it and take it out for their own development. However, there's still the question, how does the business model evolve from there? Who actually gains what advantages out of those environments? And what do I need to do as an OEM to make myself ready to take out capabilities out of these initiatives? And this boils back to what I've said before. If I don't invest into my capability setup, I will not be able to actually get those advantages out of these initiatives as others are able to do so. Engelbert, what's your point?
I trust that in the long run, we will have this common stack of knowledge or this repository where we all contribute to. At the same time, I doubt that the speed of these developments will be impactful enough so that we can benefit from that in the next 5 years or in the next 8 years. So there is 1 or 2 software cycles that we need to develop with our in-house capabilities, and where the race is very much open on how that software stack can be defined in the future. And we will see very different architectures. If we look into, what do I mean by architecture? I mean a software architecture. What do I mean when I say software architecture? You already spoke about these API contracts, but software need to be defined in a way that it is that security is like in the banking industry embedded and there is a zero trust security architecture in the software, because you cannot firewall from the outside and then the rest of the software is sitting inside in a zone where security does not matter. It's way too complex to have a software adapting through a firewall. It needs to be embedded. Diagnosis needs to be embedded. It needs to have, rollback capabilities. If there is an update that you cannot trust, it needs to be rolling back to a standard, to the version before. So the avalanche of problems that we need to fix is so huge and requires so much reaction agility that the time to agree across the bodies of unification and roll out something that is an industry standard will be too long. And by the way, if we are across the board at the moment per annum spending 100 billion in the industry on software, I would also want to make sure that I have a decent share of return on this software. So there are complex questions that we need to discuss before we get it back from a public body where we participate in a common pool. We have this, we call it Allmende problem, where everybody wants to get more back from the common ground that is investing. Over the long run, 10 years, I'm with Holger. Until the end of the 10 years, it will be a battle.
I struggle to see a common software working, because I think this is sort of like engines. The OEMs all designed their engines, and this is what's going to give the car personality. We used to look at it as the internal combustion engine, that it was the roar, it was the performance, that was the defining characteristic of a car. My first projects working with electronics in a vehicle were radio systems, navigation systems, infotainment systems. People get in, the first thing they do is they touch that, they turn that on, and it's sort of the car as a consumer electronic device more and more these days. So for me, there are just paradigm shifts that are happening. And suppliers right now want to produce these black boxes that they give to the OEM, where they own the hardware, they own the software, and they interface. Is that going to work in the future, or are we going to see less of those? Ingeborg, you suggested this in your presentation. Are we going to see less of those black boxes where the suppliers own that, and that's how they make money, by selling that black box, which is self-contained, or with the OEMs taking that over? Or is that going to continue to be a way that we see the industry progress?
My prognosis is firmly that we will see this disappearing. This is, the best sail ships have been built when the steam engine was already rolling out, and this is like delivering the last sails to the sail. You can still have sails out there today. Yeah, you can have hobby sailing, and I learned that some of those cargo ships are getting sails now on top. But that's a development that will come maybe again in 2 decades time. But yes, I see that the classic black box is a dinosaur. Holger?
I fully agree. Nothing to add. Yeah, completely agree.
So what does that mean for suppliers? This is, for me, this is earth-shattering, because a lot of the electronic suppliers, that's how they make their money. They make their money selling these black boxes that they control. This is a paradigm shift, and I don't see anyone being ready for it.
Yeah, if you have a very narrow perspective on the technology in front of us, that could be true. But I'm a strong optimist. I think for me, the future is very much richer than only contained to a small level of cost control. I see a world of abundance where robotics will play a major role, where we have much more service capabilities, and you will be served across the planet with much more function, where this is just the entry gate to an abundance of robots that bring services to you, and not you drive through the city all the time, where not only a pizza will be delivered, the complete cooking robot will deliver the meal that you want, where the service industry will completely reshape the form that it has. So I'm an optimist by what we see. It will be more energy efficient. It will be much more intelligent. It will be a contribution to a world that we will like to see.
And if you look at the suppliers today, you see them already deviating into service-orientated business models, right? Be it in-car shops where they build a business model so that others can actually deploy software into the vehicles and they earn a fee by supplying those into the OEMs. You see MNOs who are trying to create additional business streams or business models around the classical, I enable the SIM management in a certain area of this world. But in addition, I try to make some additional business models out of the data I can gather out of certain areas. I can supply, be it emergency call capabilities and so on and so forth. So you see them already starting to deviate out of this classical black box situation. But always the question is, what does it mean to me as an OEM? How do I build this into? How do I make a complete visible environment for my customers so that they understand what's in for them if they buy actually my product at the end? And not so much, is it worthwhile for the tier one supplier or for the supplier? For me as an OEM, that is kind of the second question I have to answer.
May I quickly add a little bit to highlight also my sentence before that not only the service ecosystem will change, if a car is operating in an autonomous fleet, let's say 16 of 24 hours on the road, the cost level that you can embed, the comfort level, the value that you can embed into this car, because it is serving you a much longer time over the day, you can create a completely different piece of value, and it can do much more. It's not customized like in the past, where most of the day it was sitting on your garage. We had a question here from Kevin. How will software notifications and updates be provided with many different OEMs and vehicle platforms around the world? A very good question. Currently, we see very closed ecosystems. Within these ecosystems, you will not find one software stream. Unfortunately, you'll see many variants of software that need to be maintained. That drives lifecycle costs. And every OEM is suffering from those lifecycle costs like crazy. So the notification is not only different, across the OEMs, it is also different within the OEMs across their platforms, across legacy systems and legacy operating models. That's very expensive. And here comes what Holger has said, that in this area of the updates, standards could be provided very much like autos are. So you could have security and update standards, at least for some services, in a certain layer. Above this layer, the functional updates will be different ecosystem by ecosystem. And that's an area of competition. Holger?
Not only competition, in addition, it's also product compliance. At the end, the OEM is responsible for complying with all the legal and functional and non-functional requirements imposed on his product, right? And so there's simply no way around that I'd be able to have this capability in-house.
Yeah.
This again goes back to the question, how do I make that happen? How do I secure that this works? How do I work together with legislations and homologation processes and all these other things? This is the question to ask.
Yeah. And it drives complexity, it will drive cost, and it drives, of course, scale effects across ecosystems. So the first one who can scale the quickest with his ecosystem in one standard, of course, has a significant advantage. My prognosis is that for standards, we will see alliances. We will not see a unification across all the OEMs, and it will be, we already have two major stacks that will not be unified again in the future, which is China and the rest of the world. And we could see several global stacks that are technology-wise competing. That could be, bound to various hyperscaler systems. It could be bound to software chains that are very different. It will be bound for sure to the OEMs and their sphere of influence. So that will be an interesting battle, and function and cost will be weapons in this race, and speed.
AV, lucky enough to use software out there for each companies. You talk about how do we take cost out? Because $1 billion is a massive amount. How do we optimize here with?
I'm sorry, I did not understand the question clearly. Maybe you can write the question in the chat, because that came across quite scrambled. Holger, did you understand it? Then I give it over to you.
No, I wasn't able to understand. But I think one of the questions always comes up is, how do we, I mean, let's assume we understood there are some things necessary in order to make things happen in the future. How do we get started? What do we need to do in order to migrate from our current organization, which is obviously used to work in a certain way as of today? And how do we help them move into another way of thinking, another way of software development driven product development at the end? So probably we can have a look at this question.
Yeah. So if we, you know, there are some first of all, what we did years ago was we had departments of concept development in our OEMs that would develop certain concept before we roll them out into the practical use. We need to support the OEMs to go back and have, again, the capabilities to do concept development in the architecture trajectory. Yeah, so we need to have certain architectural principles developed that we then can use and apply when we, you know, move ahead with our trajectory, with our evolution of architectures, and make software that we develop more like a product and not like a project. Because a product is something that you develop amongst partners that has a backlog, it matures along a certain process and a certain trajectory. A project is something that is finite. Yeah, you give it a scope, you give it a time, you give it cost, and you think that then you accept it and it's done. That's the classic engineering thinking of the mechanical engineering world. And a product is something that has a temporary character, where you have a backlog, where you try out things in a certain framework, and then you get feedback from the customer, and then you develop it as a product. This thinking of product development will be very much the understanding that needs to be applied when it comes to software development. Maybe Holger, you can say something about your recent, couple of projects and their experiencing working in an OEM space and how that needs to be learned and transferred.
Well, I mean, basically at my area, it was very much legal driven, right? So before you have been able to put anything in front of a customer, you had a legal check, and most of it was actually being denied because of the task of a legal organization to avoid having any kind of risks imposed into the company, right? And so this way of working was, you wrote down the functionality you would like to develop, then you get an approval for it, you get the funding for it, you get the team. This already is a year of working, right? You would probably develop the function in a modern environment in probably, 4 to 8 weeks. But only the preparation time is more than a year before you're actually able to get started, right? And this thinking has to change completely. You need to think from the customer backwards and see, how can I actually put functions securely, safely, compliant in front of the customer without having all my organization stuff built around it. And there's a good example. I've been working with an ADAS partnership organization. We've been able to, from the identification of an edge case in a test vehicle through all their development pipeline with tons of data, to changing their machine learning algorithm, retraining it, to put it back on ZIL into the vehicle, less than 8 hours. Right?
Wow.
This is something you need. But now, even though this is a huge capability this organization is having, this is just one domain, a very important domain, but only one. It is not referring to safety and security parts like braking, whatever, steering areas. It's not to infotainment. It's not to whatever else, right? And so the challenge those organizations are having is, how do I build this in a multi-domain context? So that's not only one domain, which all of the OEMs, as far as those I know of, do have. Most of them have it in infotainment, some others in ADAS, some others in some particular part. But how does this work together that you have at the end a functional, working, virtual environment where everyone globally can develop against, validate their development, and be clear that what works, what has been developed, works after the first smoke test and can be deployed to a test vehicle.
Well, Holger, part of what you said there is they can push changes out to a vehicle in 8 hours.
Yes.
So for me, that's mind-boggling. I watch what happens now, where we go through software is developed, we go through test cases, we're spending months testing it before we push it out to a vehicle.
Yeah.
I mean, is 8 hours the new timeline that we're going to be targeting for everything? And how do we do that?
Well, that speaks to two things. First of all, if you want to have a sequential development process where you do the testing as a separate box after you have done the coding, you have lost before you have started. There need to be procedures in the architecture and the software architecture that allow you to do testing embedded. Yeah, in every node and across the system, there needs to be embedded testing. That does not work yet as it should, but that's the aim of it. I like the question that has been raised here. Where and why have OEMs and larger tier ones failed at this, and where have been successes? Our major failure area of concern is that we have organizations that are built by the principles of mechanical engineering. We have the V model as the reference architecture, how to build and to do projects. The V model is not the reference model for building software. It's the continuous integration, continuous deployment cycle that defines how software is being built. If you build it the classical way, you decompose your larger problems in small problems. That's the V model, yeah, from your requirements to the test and integration. Then you will end up at the rear end of the V model with integrating some stuff that has never been tested together, and you lose all your power in the integration piece. Yeah, and the integration piece in these complex systems are so hard to do that all the remaining overhead that you had built into your projects will be eaten up. It is time, it is cost, it is complexity that is cannot be managed at the rear end of the project, and that's where we fail. If you understand that the method of working is not the right one, then you also understand that you cannot train another method of working to people that have not seen the other process working. And wherever you have people that come from the software industry that see the new way of working, you have a chance, not a guarantee, a chance to win. When you want to transfer the old thinking into the new world, you will fail. This is another generation and a thinking model that needs to be applied. And if you're still not having a software guy running these software units, my message is pretty much you will not succeed.
Ingobert, that takes me to just thinking about companies that are out there. I think Tesla with Elon Musk, he's much more of a software guy than he is a hardware guy. When you look at his background, I look at other companies that are really trying to play in the AV space. I look at Zoox. Zoox really seems to be a software-driven organization, and they're developing their own hardware. They're controlling the entire ecosystem themselves, and seem to be really doing it in a strong way. And they're being very deliberate. They appear to be deliberate. I'm privileged to ride in one in Las Vegas, see how they're running. It's pretty amazing. And then Waymo's out there, which is Google backed. They've got the deepest pockets of anyone.
Yeah.
And we're seeing them go out there riding in a Waymo through the San Francisco streets over the summer was absolutely incredible. And I had the privilege of doing it earlier in the year. It's wild to be in these vehicles. And I see so much opportunity for added services that they can sell and other things that they can do. But getting to that point and putting that software together seems to be such a large undertaking. And we've got NVIDIA, we've got Qualcomm, both coming up with self-driving stacks. are there going to be software stacks that lie on top of the vehicle that's sold to consumers, or are we going to see new players coming in and dominating the automotive world?
Holger, your thesis first.
It's a very good question, and I strongly believe the decision point will be in the next probably 3 to maximum 5 years where this has been decided.
Yeah.
Most of the OEMs still invest into their own capabilities to be able to have a software stack, at least in the vehicle, who's controlling their capabilities to enable them later on go this path from level 3 to level 4 to finally probably even level 5 at some point in time.
Mm.
But the way they're doing it is most of them utilizing those way of working we've been discussed so far in the past 30 minutes. So it's going to be an interesting factor to see how they move forward. You see today, Qualcomm is having one of the leading chips for inferencing in vehicle, right? So a lot of OEMs are actually relying on them. And again, this is the same discussion we had with the tier 1 suppliers earlier. Qualcomm is always also trying to enlarge their piece of cake. So coming into the software layer, not only the hardware part, right? So coming up with a software development stack and being probably able to, at one point in time, having an ADAS stack which they can sell to others. We see Mobileye who are doing this today already, right? We see other companies who are in that space. And
NVIDIA.
It's been interesting. NVIDIA, and it's going to be interesting to see how this is going to evolve. But I don't believe that it's going to be one takes all. That would be far too risky for the OEMs. So you will see a couple of those, and there will be some OEMs who will be able to deal with that capability and be differentiating. And there will be others who actually, I would say, already gave up on that string and will become the hardware producer, who's then producing the shell around software others are being supplying.
What you ask is something that, you know, on a major level, all the OEMs think and dream of being the Apple of mobility and have a controlled ecosystem where everybody needs to participate and pay for play. The reality is that exactly those OEMs that have these power dreams are not capable of delivering an integrated taxi app into their ecosystem that really works across the globe. Yeah, so the reality is that the capability to deliver software on a global scale and the reality to deliver it reliably versus the dream of being universal powerful is ridiculous. I think that we have maybe 5 more years to define it. And my prediction is that it will not be one of those classic players that will play this game. Yeah, our capability, our speed is just not there. If we look into how long it needed to understand the data that is creating the value and the importance of data, and we are still not harvesting data by far compared to what Tesla does. Yeah, we are still not capable of putting some value behind the data that we collect. We still have a long way to go to create ecosystems that allow us to have another layer of orchestration sitting on top of where we are now to deliver advanced business models on top of it. So that remains a challenge. Our current challenge is to drive the cost out of the many variants that we are delivering and create a software stream that even allows us to handle the next generation that we roll out to the market. Let's look into some of those questions so that we're not missing out on those ones. Kevin writes, speaking of lifecycle and OEM ROI, what is the early general speculation related to OEMs or service provider support for providing updates and upgrades leading towards obsolescence? That's a tricky one. We need to roll out many of those legacy platforms and maintain them. Massive cost burden already to the existing OEMs because they have the tendency to put a lot of the software into obsolescence, and legally are being bound to provide updates for the next 15 years to come when they roll it when it ends production. Yeah, so if you start a platform now and you plan for it, let's say that it runs until 2030, you will need to legally maintain the platform until 2045. If you do that, let's say 10 times until 2045, imagine what legacy that you need to manage. The good news is there is opportunity for AI to do a lot of automatization and to learn how to maintain those platforms. And I think that, again, I'm an optimist, that technical capabilities will also be enhanced and more productive in the future to not only maintain those platforms, but also to iron out some of the errors that were delivered in the first place. Holger, how do you see that?
I would just add that you have product managers who actually monitor the performance of your functions in the field and drive decisions on probably taking out certain functions from existing vehicles because they've not been used efficiently, or there are some legal constraints which haven't been part of the original development, so that you are able to actually play different business models in front of the customer, as long as it's not integral part of your security environment of the vehicle, obviously. But if we talk about infotainment functions and others, you need to be able to understand what your customers actually are using, how they are using it, and then be able to play that with your customer base in a very positive manner. And we see a lot of examples. Not all of the Tesla functions are still in the vehicle, or they have been sourcing them out to someone else who wants to bring it in. There are marketplaces up and running where you can securely deploy software into the infotainment. There are a lot of different ways of kind of orchestrating that in favor of your customers.
And I want to be a little bit of a pragmatist here because everyone else seems to be being optimistic. So I've driven software-defined vehicles. I've had a Tesla since 2013. So I was a pretty early adopter. I had an early Model S, and I've got a couple of Rivians. I've got a Model S, the one I have right now, I got in 2016, and it's still a great car. It's a server on wheels. But what I've noticed over time is that as more and more updates come out, and updates come out all the time, it takes longer for the vehicle to start up. It takes longer. Some things start to lag. Things are designed for the more current, faster processors. And part of my pragmatic concern is that we're optimizing for the latest vehicle, not necessarily for the legacy vehicle. So we have to think about that and take that into account. The Rivians that we have right now work perfectly, but they're 3 years old. They're early, but they're not that old yet. So we haven't seen time for that to lag. We've got other newer Teslas.
Yeah, unfortunately, Ambrosi got kicked off, at least from my stream, but I think he's making a good point.
Sorry, I'm having a challenge here, and I apologize to everyone today.
Go for it.
It's really about how do we look back and how do we optimize this? Because we have these servers on wheels. And I mean, this takes me to, we're going to be at CES, and we're going to be having some meetings with companies there about how they can really start to participate in the software-defined vehicle chain. How do we look at this, and with all of that challenge, even that the OEMs are having, how does that become better? And how can suppliers help? How do the OEMs do it better? And how do they do it with less? Because these software engineering organizations are massive. AI is coming into play. There's so much going on. And I would think that there would be ways to better test, to preserve that legacy fleet without having to lose a lot of the capabilities. And maybe you don't get as many new features, but you get the performance to stay at a good level. Keen to get your views, Holger and Engelbert.
To me, it boils down to the question on how do I test and validate my developments in a way that I can actually serve all of different hardware variances I have out in the field. And let's look at the company like Microsoft, how they're doing it today with their Windows environment, right? They serve all of different platforms, and they're able to test and validate it before they actually put it out in the field. And even if you look at the future updates, they will not require you to restart your laptop or your computer. It's being incremental, smaller updates which are being played into the system while you're continuously working. And you will see similar capabilities on those OEMs as well. And look at Rivian or Tesla. Until today, there was no need to deal with this question because their hardware was strong enough to supply all of the different functions the developers were able to put on it, right? But that's going to change. And guess what? With this change, there's a new capability I need to learn as an OEM to be able to cope with this and to be able to make a configuration management, which enables me to supply some of the functions in some vehicles and others probably not at all, or probably in a reduced way into vehicles who might not have sufficient compute power or sensors built into the vehicles as the newer ones.
Yeah, let me first be a bit nasty, because the problem that you describe is one that most of the OEMs will not have, because they're not good in over the air at all. Yeah. So
Fair. But they have to get there, right? If we're talking about needing safety updates pushed out in 8 hours, they have to figure this out.
Yes, but then exactly what Holger is describing is the holy grail of software definition and software architecture and software engineering that we need to achieve, which is getting to a software that you can parameterize, that has these switch on, switch off functions where you have modules that fit then into the software or not. Yeah, you can still update an iPhone that is generation 8 today with iOS that we roll out. Yeah, so that's 10 versions before where we are now. Very interesting to see software development methods that are capable to do that. And by the way, this is also something that remains to be seen from the new entrants, because they have learned now to fix one or two models, but they have not learned to put parameterizable software out there that caters various generations of vehicles and various brands in parallel, various vehicle classes, and managing this complexity remains to be seen. The jury is still out on that.
So if we think about what suppliers and OEMs should be doing, and we're thinking about CES, we haven't even touched on heavy duty, what trucking companies should do, because I think there's a massive opportunity there.
Yeah.
What do we want people to be thinking about? Why would they want to come talk to us at CES? We're near the end of this, so I'm gonna allow us to put in a plug here.
Well, there are very good best practices that we can talk about on how to set up a software organization that is actually functioning and delivering. I think that's something that after 15 years of trying, we can for sure bring to the table. We can also compare it with best practices from China and from other industries. There is industries that have already been solving some of those puzzles way better than the automotive industry. And it absolutely pays back to open the bench to some of those industry experts and onboard some of those very capable people to make sure that those very, very, very expensive errors that we have seen over the last 5 years will not be repeated forever.
Fully agree. I also think that there's a huge opportunity here to talk about how do you change your product development process? How do you take time out? And there are huge efficiencies right now that we're seeing in ways that we've benchmarked, in ways that we can look at taking time out. Because if we can take 18 months out of the product development process, that becomes a completely amazing opportunity. There is so much money spent. If we're talking about 100 billion in software engineers annually spend, then if you take time out of that, that becomes fantastic. If we can take 50% or 30% out of that, or even pragmatically saying we get 20% out of that, that is a massive savings. So we can either do a lot more or we can save money. And in an industry that's struggling financially, I think that's a huge opportunity. But there's a lot more to talk about than that. And there's a huge opportunity for both the consumer side. How do we make these servers on wheels work better? How do we add functionality? How do we sell more and add value? The subscriptions that we're seeing from Rivian and Tesla and others coming into vehicles right now, adding enhancements through software. And then on the commercial vehicle side, how do they add more tracking, more assistance? I think we'll see, from an autonomy perspective, road trains in places like Texas before anywhere else. Overnight, seeing maybe a pilot, but maybe not, with 15 trailers on the back of a tractor. I think there's huge opportunities. So we're about out of time. We'd love to meet everyone at CES. We'd love to continue this conversation. Holger, Engelbert, I'll let you have some closing remarks.
Well, it was absolutely a pleasure to be talking here today. I hope that you feel that we are really excited about this new wave of automotive industry that lies ahead of us. I am a deep believer that this can be fun. It can be value. it can be an adventure, and we should embrace this opportunity to shape the decade ahead of us and not be afraid.
Yeah, building those capabilities we've been talking about is a huge step forward. The advantages are tremendously great, but there's also quite some steps to be done by the OEMs to get there. So happy to be part of that, and thanks for the discussion today.
And Engelbert, it's hard to believe it's been more than 20 years, but kind of amazing. There's so much opportunity out there, and this is an industry that keeps changing. Holger, Engelbert, thank you so much for joining. It was a great discussion. We've only scratched the surface here. There's so much more to go through. So we look forward to talking to everyone. Please feel free to reach out, scan the code, email any of us. We're happy to get together at CES in January or have a discussion before. Thanks very much. Have a great day.